Have you ever stopped to watch a flock of birds float through the sky in perfect harmony, or seen a school of fish move like one giant organism? It may look like magic, but it's actually not. Let's dive into the subject. This topic inspired my project on collective animal behavior. To understand how it works, I set out to do some research and I learned some interesting properties. At first, my goal was to simulate a school of fish using robots, specifically epoch robots. However, during the process, I ran into some technical issues and I had to pivot. Instead of creating a physical simulator, I created a web-based interactive simulator that can help us visualize the schooling behavior. To create my simulator, as I was diving deeper into my research, I found tons of mathematical models. But I decided to go for the one that had just 3 simple rules but could still help us create realistic schooling behavior. Now I'd like to explain the rules to you. Don't worry, I'll not bother you with the technical details, I'll just help you visualize the rules with my illustrations. You can think of each fish as having 3 circles around it, and each circle represents a rule from the set of 3 rules. The first rule is the repulsion rule, and it is represented by the innermost circle around the fish. Each fish tries to keep a minimum distance from its neighbors to avoid collisions. Think of it like a personal bubble. You don't want to be bursting other people's bubbles, right? The second rule is the alignment rule, and it is represented as the second circle around the fish. When fish aren't avoiding each other, they try to align themselves with their neighbors. They do that so they can all swim in a coordinated way. And finally, we have the attraction rule, which is represented as the last circle around the fish. When fish aren't avoiding each other or aligning themselves with their neighbors, they get gently pulled toward one another. They do that to maintain a certain cohesion inside of the group. To bring this model to life, I use mainly HTML and JavaScript with a creative coding library called p5.js. Now, enough talking, let me show you how the simulator works. As soon as you get on the page, you're greeted with some information and can go ahead and click on Go to the simulator to get to the simulator. And now you can see the different fish. You can pause the simulation, play it again, and drag your mouse over the canvas to add more fish. You can also reset the simulation. Now we can play it with different parameters such as the maximum speed and the repulsion radius to see how the different fish react to each other. We can also set the orientation radius and the attraction radius. We can also play with the blind spot, which represents how much the fish can see around themselves. When you click on Learn more about the model, you can get more information about the model I used to design this simulator. Swarming isn't just about fish. It's being used in robotics, autonomous drones, and even in medicine for things like nanobots targeting cells. Thank you for watching this video, and I hope that I have given you a little more insight on how computer science helps us simplify complex behaviors.